My name is Michał Taszycki. You can find me as Michał T on any social media platform. I work full-time on the 64 Bytes project, which is a series of screencasts for programmers that want to learn how to program Commodore 64. But today, I want to tell you that test-driven development is easy, and even if you don't have a testing framework, you can write your own yourself in just few lines of code in any programming language. For example, assembly. Here we test the macro that adds two numbers together. So we compare the result and we jump to the part of the code that changes the border color to red. And if the test pass, we change the border color to green. So at the beginning, tests fail. But when we add the proper implementation, tests pass. So I was curious, how hard could it be to write a testing framework in assembly on Commodore 64? So to answer that question, I did just that. It's already published on GitHub. It's called 64spec, and it's heavily inspired by the rspec library that is highly popular in the Ruby community. And it looks like that. So again, we are testing the same macro that adds two numbers together, but we have two test cases. So we need 3 lines of boilerplate code in every test suite, and then we can test the code. So we have proper assertions, and the cool feature is that we can describe every test with some text, which becomes a living documentation. So when all tests fail, everything is red. But when we add a partial implementation, so we return 3, the first test should pass, and the part of the documentation turns green. With the proper implementation, everything is green, and we have confidence that our documentation is synchronized with the test suite. When you're writing a testing framework, you need to make sure that every assertion works 100%, works. So you need to test it. And this is challenging when your computer has 64 kilobytes of RAM. Basically, you need to split your test into multiple files, and trying them by hand gets tedious. So the next step would to be write a runner in a command line. And this was surprisingly hard, because the test suite runs on the Commodore 64 in an emulator. So you need to get the result out and somehow put it on your screen. And then you need to close the emulator, and you can't do that from the program running on Commodore 64. Well, actually you can. New version of my emulator supports closing itself when the computer crashes. And you can issue an assembly command, illegal assembly command that crashes the CPU. So I did just that. But there was another problem. The newest version of the emulator runs on Windows, and I work on a Mac. So this is my final solution. So first I needed to create a runner on command line. Then I needed to decide which language to write the runner in. So I decided to go with Go, because I didn't know the language. But I quickly discovered that Go allows us to write a parallelized code really easily. So I spin off multiple instances of Wine, which is a Windows compatibility layer, which runs the Windows version of the emulator, which emulates the Commodore 64 and runs our tests. So when the tests finish, the result is written on a floppy, which is mapped on my hard drive, and then the computer crashes, the emulator closes, and everything works. And the best part is that it really works, and I'm going to show you. So this is the test runner. If I run it with multiple specs or tests, then it compiles everything, and then watch at this space at the bottom of the screen. Wait for it. And believe me, it's much easier than doing it by hand. So, if you want this beautiful sticker on your laptop, find me after the talk. Thanks.
Okay, thanks, Michał.
Hi. Hello. My name is Adam.
and I work at API. We build a lot of interesting tools for convenient API development lifecycle. And today I'd like to tell you about what I do at API, and it make me like convinced me to give this little lightning talk. The presentation Kirsten had 2 days ago about how to build an API in 4 different programming languages, and there was a good question in the Q&A how to test it, or if she's acceptance testing it. And Kirsten mentioned several API description languages, and one of them was Swagger. And we recently added support to Swagger, of Swagger to API. This is Swagger. Swagger document. It's a YAML file, and this is the documentation generated from that API description. And this description, it's like a human-readable documentation on one hand, and then machine-readable specification. You can actually run tests against. And that's what I do in API. This is Dread, and Dread is a language-agnostic testing framework for HTTP APIs. And because HTTP is kind of lingua franca, it makes you it's a bridge language between several programming languages and softwares and services. You can use different programming languages within your company and use one lingua franca, and the way how to speak about lingua franca, about your APIs, about your HTTP APIs, and that's that API specification. So Dread pulls in the API specification, and it runs HTTP transactions against your backend. You can write backend in several programming languages. Dread supports Go, Node.js, Perl, PHP, Python, and Ruby, so you can have bindings to your language and use your native tools like Factory Girl in Ruby, etc. And manipulate the database and isolate test cases. And I'd like to give you a super quick demo. All the documentation is here you can find it on Readerdocs. There are thousands, a lot of examples in a particular language, and I'd like to show you how it works. So I have this super simple API with one endpoint. I have my Dread already installed. It's a npm package, so npm-g install Dread. And when I do Dread init, oh wait, this is the Swagger. So I have a Swagger here. I have the implementation here. And the implementation is actually commented out. It's my Express application. So it's commented out. And when I do Dread init, it will actually walk you through the initialization of Dread in your project. So where's your API description document? Mine is swagger.yml. How to spin up the backend server. In my case, it's node app.js. And this is the URL where the backend is listening. Here you can pick your poison. In my case, it's Node.js. And this is a convenient feature that Dread can visualize your the HTTP traffic, because it's a complete data and it's very hard to read into this complete data in the console. So API can visualize the calls. And if you have already existing continuous integration set up, the Dread will plug in your continuous integration. I'm not going to do that. So let's Dread. It's starting the backend server, and it's failing. So it's failing, and when I uncomment the implementation, it's passing. Whoa. Okay, that's it. So with this tool, you can have always in sync your documentation and implementation. That's it. Thank you for your attention.
Thank you.
Okay, so I'm going to do a little musical, quote-unquote, demo of Overtone and Emacs. And we learned yesterday that it's very good to experiment and that it doesn't have to work and doesn't have to finish it. And as long as you learn something, I'm going to add an extra rule because I'm going to inflict some sound upon you. The fourth rule is that it doesn't have to be good. So off we go. How does that look? Okay, that's cool. I'm just improvising. I got some ingredients, but like we'll see where we end up, right? Oh yeah, I'm forgetting something vital. No, I can't see my cursor. Wait for it. Seems like it's having a hard time keeping up. I'm almost there. Okay, I feel stop. Yeah, so this is called Overtone, and the thing with the graphics is called shader tone. And this was my gateway drug to Clojure, so I recommend you check it out. You have no idea how much fun it is.
Hi, I'm Krzysztof. I work at Codeity. I'd like to talk a bit about Git tricks, some small tricks you can do. I have a single repository with a file. Let's take a look. The exact contents is not important. It's kind of files you write when you use that when you write Django views. Let me add another view. Call it view 1a. Let's look at the div. And notice that the div is garbled. I added those 3 lines, but in fact, Git displays this line. It's pretty confusing. If you use a recent Git, you can use git div compaction heuristic, and it displays a nice GIF. You can even make it default. And there you go. It's a pretty nice setting, and I recommend enabling it. You need a recent version of Git. Here's another thing. Let me make a commit. So that's how you normally do it. But you can add the verbose flag, and then you see the div, you changes, right below the commit, right above the commit description. You can also enable a config setting called commit verbose to make it default. Auto function. Okay, so what is a commit? Well, you can type here. This is a commit. Git cat file -p displays information, and you can see that a commit is a record structure that is composed of a parent. There can be, usually it's 1, but it could be 0 if it's the initial commit, 2 or more if it's a merge commit. There is author, there's committer, there is the commit message, and there is this structure called tree. It turns out that in Git, not every hash corresponds to a function, corresponds to a commit. You can also have in the Git is really a key value database where a hash can also stand for a tree object. Which is the list of files in a particular directory at a specific point in time of the repository. So as you see, this is another kind of object, which is a blob, which corresponds to a file. So you can use hashes to index not only to point not only at specific commits, but also at directories or files. Let me now amend. You can use add sign to refer to head. Now, if you compare that, this commit is different. You cannot edit a commit in Git. What you do is you are creating a completely new commit and changing the tip of the branch to point at the new commit. The old commit is still there, and you can refer to it with a hash. But if you compare the tree, it will be the same. So what I did, I just reworded a commit, but I did not. So I reworded a commit, so the commit is different, but the tree object stays the same. So it means when you make this when you make an amend, it is a pretty cheap operation because the only thing you are adding to the Git database is this single commit, but you are not adding a tree. Similarly, if you rename a file, you will only rename you will only change a tree, but you will not you will not store any extra blob. Let me make some change in this file. Take a look at the div. So now it's pretty readable. However, if this line was pretty long, I would have to match all the pluses and minuses and see what has exactly changed. Here's what you can do. Use git div color words. And notice now the div only takes 1 line, and you can instantly see which word has changed. Another trick is that if you have a commit which mixes indentation and semantic changes that you shouldn't really do, you can say git div -w, and this will ignore white space changes. One more thing about force pushing. You know you can force push and you should usually avoid it, but as long as you are fine with it, there is a danger that someone else will push to the branch in the meantime. When you check that it's safe to force push, someone pushes and then you make a force push. So there is a new option in Git called git push force with lease. And this refuses to force push as if the state of repository has changed since the last Git fetch. Who has learned something new? Nice. Thanks.
So I threw this together yesterday. It's a unfinished project, but I'd like to ask you, who does here participate or knows about hackerspaces? Okay, good. So I am a member of this hackerspace in Brazil called LHC. It means Campinas Hacker Lab. And for those that don't know what hackerspace is, it's a place where people go and meet to do stuff. So there are usually various tools and toys to play around with. And one day I was just hanging out, and a friend bought a ping pong ball and decided to light an LED inside. So sorry for the picture, this is not really focused, but you'll see better pictures in a minute. And I thought that, okay, this might be a good idea for a project. So I went to the dollar store and bought 100 of those ping pong balls, made a jig in the drill press so I could drill all those 100 ping pong balls. Then I got a 40 by 40 centimeter piece of MDF, drew a bunch of lines, drew a bunch of crooked holes, and then put all the LEDs there, glued every single one with hot melt glue, and cut 600 tiny pieces of wire, about 3 centimeters long, stripped all of them, soldered all the single one of them, put a connector because these wires are solid core wires and they break easily, so here's another view, and tested that, it actually works. So, and there was time to glue them up, so just some also hot melt glue, began gluing all the ping pong balls, lots of them, and then more ping pong balls glued, tested, they look like this when they light up, so they diffuse the light very well. Then I got these things here. So these are really, really cheap. The module itself, this small board on top of the larger black board here, they cost about $3, and it's got a 32-bit microcontroller, runs at 80 megahertz, and even has Wi-Fi built in. So I got plenty of these boards and decided to program these LEDs. So here's a program in C that does just that. So basically loop through all the LEDs in the matrix and sets an RGB color for each and every pixel. T is, of course, for time. You will understand why I'm talking about this in a minute. But as you can see, there's a lot of craft here, right? So lots of information you don't really need. So I decided to, instead of using C to program these things, I decided to use Forth, which is a pretty interesting language, which is stack-based and concatenative. So it has very little syntax, if at all. And basically, this is called for each and every pixel, like the previous code. And it has to leave 3 things on a stack, because it's stack-based, right? So RGB. It's essentially the same code as before. And of course, being stack-based is a reverse Polish notation. So I wrote a simple for runtime, and did it work? Well, it did work. Let's see if it'll play. And this is being controlled by the Forth program. Not the program that I've shown you, but another program. And you can see there are many, many nice effects. My phone's camera can't disable the autofocus, so yeah, it really sucks. So just cycling through many effects. Okay, so why Forth, right? Well, I've used the Forth many years ago while doing some things on open firmware, which is like BIOS but for PowerPC Macs, and I kind of like the language. And I've written many Forth interpreters over the time, and talking with a friend that worked with me on these things, he told me about this site here, which is really fun. You can open it on your laptop. And what it basically is a list of really tiny programs, pretty much like that one that was on the slide, that would do some very interesting animations. So for instance, that program here is like this one, and you can edit the program right on the web page, press play, and it will run the program in quite real time. So it remembers Shader Toy if you've played with GLSL shaders and whatnot. So my idea is to put this on the microcontroller and use the fact that it has Wi-Fi, so can open a page served by microcontroller and do this on the LED panel itself. So that's it for today. Support your local hackerspace, and well, have fun.
Thank you, Leandro. Cool. So raise your hand if you use a keyboard at least twice a month. Twice a week, maybe? So, okay, that's a lot of people. So what's the deal with keyboards, right? Some people thought really hard about it, and they came up with the idea that you can divide the keys into 3 groups. And the first one is modifiers, which are keys which change the behavior of other keys. And then you have non-repeatable keys, which are keys that you press and release but don't want to repeat, like escape or insert. And then you have repeatable keys, which are keys that you sometimes press and release, but sometimes you want to repeat, like holding space to insert a bunch of spaces or backspace to remove a few characters. And the nice thing is that we can combine modifiers and non-repeatable keys into one key without losing any of the functionality. So we can make a key behave like a non-repeatable key when pressed on its own, but act as a modifier key when pressed with another key. And that's really awesome. It is. It really is. I will explain later on. So let's go to caps lock, which is quite useless, right? You have it in front of you every day, and it's like if there was a brick that was laying on your table, except that a brick can serve as a laptop stand, monitor stand, if you are in a struggling startup. But the caps lock key occupies a pretty good spot on a keyboard, right? It's pretty convenient to touch it. Was it always like that? Turns out that they got it right in 1963. They had the control right there, and that gives us some ideas. We can remove caps lock because back then they didn't have flame wars on the internet, so they didn't need that key. Didn't need to have caps lock there. So we can remove it and make it act as escape key when pressed and released on its own, but we can remember that we can combine modifiers and non-repeatable keys, so we can make it act as escape on its own, but acts as control key when pressed with another key. And it's also cool, right? It's super cool. S is mainly used by VM users, I guess, but if you're using something else, you can also remap escape to something or some other key. So what about shift keys? They are modifier keys, and remember that we can also combine them because they are useless on their own when they're just pressed without another key. So we can make them type a left-right parent when pressed and released on their own, but act as a left and right shift key when pressed with another key. And that's even more awesome, for example, if you're a Lisp developer, but even if you code like in JavaScript and you need to arrange your callback hell, right? So it really works. And actually, in 2014, the Faculty of Applied Keyboard Ergonomics at MIT found a 53% increase in efficiency. They released a paper on it, and it says it makes you 53% more efficient. So I'm Rafał. The ideas are based on Steve Losh's blog post. Sorry, I will post it later on Twitter. So yeah, thank you. That's all.
Thanks, Rafał.